In this lesson, we're going to take a look at complete cycles on a PV diagram. And it's slightly elevated level of problem solving. Not a lot of math, but a lot of concepts and a lot of really careful decoding. But I think it's an example that illustrates a number of different skills, and it'll help you quite a bit on future assessments. So let's just get a look at the overview. Looks kind of innocent, but it does have a lot of parts. So gas is taken from A to C along the curved path like this. Notice that from A to C, the volume is decreasing. So that explains the negative sign for the work done. And the heat added to the gas is negative 63 joules. So that actually means it's a loss. And so that's all what happens along the curved path. Now you can see that I have set up columns for the first law of the elements of the first law, Q, W, and delta U. So we know that this column minus this column equals this column. All right, well, and you can see I also took the first law and I solved it like I solved it for Q here. And for W, if we want to solve for W, we bring W to the other side and subtract delta U from both sides. So this would be equal to Q minus delta U. All right, well, let's go ahead and do this. So this is mostly an organizational thing. All right, so along the curved path, A to C, so the work done is negative 35. And also don't forget, that's the area under the curve too. So the Q is negative 63. And now, since we know two things, we can find out the third, right? So that's going to be a common theme. Every time you know two things on one row, you can find out the third by just applying the first law. But you have to be super careful because the pluses and minuses can make all the difference. So delta U is Q minus W. So negative 63 minus negative 35, right? Notice the two minus signs. So negative 28. Okay, and then we have some other paths. We have A to B and then B to C. And then there's going to be C to D and D to A. Excuse me. Now, along the path ABC, it says the work done is negative 48. That makes sense it's negative because the overall change in volume is going to be a negative number. It gets smaller. So along the path A to B to C. So notice I broke up into two different parts because each leg of that pathway has different properties. So A to B to C, right, is negative 48. So I can write negative 48 right there. Okay, now what else do we know? So that's stated explicitly. In the last video, I was talking about explicit and implicitly stated variables. And it looks like that's all we have, right? So it doesn't really look like enough to move forward. But there are some things that are implied. Now, if I went from A to C along this path and the change in internal energy was negative 28, remember these are unique states. So it doesn't matter what path I take to get there, as long as I start off at A and I wind up at C, the change in internal energy is still going to be the same. So this is the same, negative 28. And since we're right here, we're talking about it, if I go from C to A, it doesn't matter what the path is, then that would be opposite. So for C to D to A, that's going to be opposite. So plus 28. All right, that's great. What else are we looking for? What else is implied? Oh, right. Well, so from B to C, there's no change in volume. Those are isovolumetric. And so since there's no change in volume, there can't be any work done. So they have to be 0. So B to C is 0, and D to A is 0. All right. So we're starting to fill out this chart. This is pretty good. Now remember, anytime you know two things on a row, you can find out the third. So we know two things on this row. So we'll take a look at the heat for A to B to C. And Q, if we solve the first law for heat, then that's delta U plus W. So we're going to add these two together. Again, being very careful with signs. So negative 48 plus negative 28. Okay, that's negative 76. All right, good. Let's see if we can decode any more clues. Let's see. The pressure at C is 1/2 the pressure at B. Interesting. So this work would equal the pressure at B times the change in volume. And that's along this path. So that's along A to B. And this one, C to D, well, so the work done down here is equal to pressure at C times delta V. I'm going to write delta V going from A to B. And this is delta V going from C to D. And you'll notice that those are opposites of each other. But the pressure at C is 1/2 of B. So that's going to be equal to 1/2 the pressure at B times the change in volume, C to D. But opposite, right? So these are opposites. But otherwise, it's the same number. So that means that these two are going to have the same magnitude, but cut in half. And so the work done in going from A to B was actually right up here. That had to be negative 48. Because remember, this plus this has to be the total. A to B plus B to C equals A to B to C. And this work done has to be a positive number, but it's going to be 1/2 the magnitude of 48. So that's going to be plus 24. And then, of course, the total C to D to A is plus 24. Oh, and now we know these two, so we can calculate the third. So Q is going to be equal to work done plus delta U. So I'm just going to take things nice and easy. Don't want to rush and make a mistake. Okay, so that's 52. All right. Excuse me. Anything else that we know? Oh, there's this weird one right here. Delta U dC. Well, that's kind of interesting. It says delta U going from D to C, so going this way is 5 joules. So when we write this number down, we're always trying to consider what direction we're headed in this notation, DC, right? So this is delta U D to C. Now, every time we do a delta, we always do final minus initial. Okay, so our final stop is D, and our initial stop is C. So that means going from and that's going from C to D. Okay, so now I can write 5 here. And this number plus this number has to be 28. So that makes us 23. That's good. Oh, I know a lot of stuff now because I can now find the heat. And here's a place where we can check our answers too, because if this plus this should be 52, right? So I'm going to add these two numbers together. So that's going to be 29. And then the heat going from D to A would be the sum of these two numbers. So that's 23. Yeah, and you can see 29 plus 23 adds up to 52. So good check. That's why I compared this to Sudoku. Lots of ways of checking your answer. And I don't really have enough information to figure out the others. So let's just go forward and see if we know enough information to answer these questions. What is Q for the path ABC? Well, that's right here. So that's negative 76 joules. What's work for the path D to D to A? Oh, I know that. That's plus 24. What's Q for the path D to D to A? Well, I've got that too. So that's plus 52 joules. What's delta U going from A to C? That's negative, actually, sorry. That's in this notation. So the final is A and the original is C. Right, so this is going from C to A, and that's plus 28. And then what's Q for the path D to A? And that's right here, 23. So we actually have enough information to get everything down. And that, folks, is about as hard as they come at this level of this course anyway. Okay, so I hope this helps.